In this lecture, we are going to discuss about inequality. The relation between any two real numbers, a and b. The relation between any two real numbers, a and b, defined by a greater than b, or a less than b, or a greater than or equal to b, or a less than or equal to b, is said to be inequality. The relation between any two real numbers, a and b, defined by a greater than b, a less than b, a greater than or equals to b, or a less than or equals to b, is said to be inequality. The alternative definition of inequality is a mathematical statement containing the sign greater than, less than, greater than or equal to, or less than or equal to is said to be inequality. A mathematical statement connected by the sign greater than, less than, greater than or equal to, or less than or equal to is said to be inequality. So let's look at some examples. 5 is greater than 3. If we take two numbers 5 and 3, then we can write 5 greater than 3. The relation between 5 and 3 is greater than. Similarly, the relation between 3 and 5 we can write as less than. X greater than or equal to 2. Y less than or equal to 9. So these type of relations which are connected by greater than, less than, greater than or equal to, less than or equal to are called inequalities. So these all are called inequalities. Properties of inequality. If a, b and c be any three real numbers, then number 1, a greater than b implies a plus c greater than b plus c. So this is the first property of inequality. A greater than b implies a plus c greater than b plus c. That means if we add same number on both sides, then again we get the same relation. That means a greater than b implies again a plus c greater than b plus c. Second property of inequality is if a greater than b, then it implies a minus c greater than b minus c. That means if we subtract same number on both sides, then again we get the same relation. That means if a greater than b, then again we get a minus c greater than b minus c. The third property of inequality is if a is greater than b, then we can write ac greater than bc for c greater than 0. That means if we multiply by some positive number c on both sides, then again we get same relation. That means ac greater than bc. We'll get ac greater than bc for c greater than 0. That means c is positive. And the fourth property of inequality is if a greater than b, then it implies ac less than bc. That means if we multiply by c on both sides for c less than 0, that means if c is negative. So if we multiply by negative number on both sides, then we'll get just reverse relation. So greater than will change into less than. In the number system, next we are going to define absolute value. According to the definition of absolute value, the positive value or the numerical value of any number is called absolute value. The positive value or the numerical value of any real number is called absolute value. So mathematically, if a is any real number, if a is any given real number, then absolute value of a, the absolute value of a is denoted by two vertical lines. The absolute value of a is equal to a for a greater than 0. So if a positive number is given, then absolute value of positive number is the number itself. The absolute value of given real number is minus a for a less than 0. That means if the given number is negative, then absolute value of negative number is equal to minus a. This is the mathematical definition of absolute value of real number. Now let's take some example of absolute value. Example, the absolute value of 5, or we can say modulus of 5 is equal to 5. If the given number 5 is positive, then modulus of 5 we can write equal to 5. If 5 is negative number, then modulus of negative number 5 is equal to 5, because according to the definition, modulus of negative number is minus times the given number. So minus minus plus. So absolute value, or we can say modulus of any real number, is positive value. Now let's look at the properties of absolute value. If x and y are any two real numbers, then the absolute value of the product of two real numbers. That means absolute value of x into y. We can write separately as absolute value of x into absolute value of y, or we can say modulus of xy is equal to modulus of x into modulus of y. The second property is modulus of x by y. The modulus of x by y, that means if x is divided by y, where x and y are two real numbers, then the modulus of x divided by y is equal to modulus of x divided by modulus of y. The third property of absolute value is modulus of x plus y is less than or equal to modulus of x plus modulus of y. So this property of absolute value is also known as triangle inequality. The modulus of x plus y is less than or equal to modulus of x plus modulus of y. The fourth property is modulus of x minus y. That means if we take the modulus of difference of any two real numbers, then the modulus of the difference of any two real numbers is greater than or equal to modulus of x minus modulus of y. Property number 5, modulus of x minus y is less than or equal to modulus of x plus modulus of y. Property number 6, modulus of x is always greater than or equal to the given number x. Number 7, square of the modulus of any number is equal to the square of the given real number. Let's look at the first property of absolute value. Let's look at the proof. Modulus of x, y, we can write equals to modulus of x into modulus of y. We know the square of the modulus of any real number is square of the real number. So we need modulus of xy equals to modulus of x into modulus of y. So x replacing by xy. So modulus of xy whole square will be equal to x replacing by xy. So we get modulus of xy whole square equal to xy whole square. This means x square into y square. Again, we know by the property of absolute value of real number, x square of the modulus of any real number is equal to the square of the given real number. That means x square we can write equals to modulus of x square, y square we can write equal to modulus of y square, because square of the modulus of any real number is equal to square of the given real number. Now if we cancel square from both sides, then we'll get modulus of xy equals to modulus of x into modulus of y. So this is the proof of first property. The second property of absolute value of a real number is modulus of x by y is equal to modulus of x divided by modulus of y. We know square of the modulus of any real number x is equal to square of the given real number x. X substituting by x by y on both sides. That means modulus of x square will get x by y, modulus of x by y whole square equals to x by y whole square. So replacing x by y. So x by y square means x square by y square. Again, by the property of absolute value of real number, x square and the value of square of modulus of x, they are equal. They give the same value. Y square we can write square of modulus of y. Now if we cancel square from both sides, LHS and RHS, then we get modulus of x by y is equal to modulus of x by modulus of y. The proof of the third property of absolute value of a real number. The third property of absolute value of a real number is modulus of x plus y is always less than or equal to modulus of x plus modulus of y. Modulus of, or we can say absolute value of the sum of any two real numbers is less than or equal to the sum of the absolute value of the first real number and the second real number. So let's see the proof. We know x square is equal to x square. Square of the modulus of any real number is always equal to the square of the given real number x, because they give the same positive value. As we know, modulus is the positive value or numerical value of any real number. So x substituting by x plus y, then we get x plus y whole square is equal to x replacing by x plus y, then square as it is. X plus y whole square is equal to x square plus 2xy plus y square, using the formula of a plus b whole square, a square plus 2ab plus b square. Now again, using the property of absolute value of real number, x square and the value of square of modulus of x, they are equal. Y square and the square of modulus of y, they are equal. So replacing x square by modulus of x square and y square replacing by modulus of y square. Now this we can write less than or equal to modulus of x square plus 2 times modulus of x into modulus of y plus y square, because x is less than or equal to the modulus of the given real number x, because x can be either positive or negative, but the modulus of x will always give positive number. So positive number is always greater than the negative number. So x we can write equal to modulus of x, or x we can write less than modulus of x. Similarly, y we can write as equal to modulus of y, or y we can write as less than modulus of y plus y square. Modulus of x square plus 2 times modulus of x into modulus of y plus modulus of y square we can write as modulus of x plus y modulus of y whole square. So now square we can cancel from both sides, then we'll get the value of modulus of x plus y is less than or equal to modulus of x plus modulus of y. After cancelling square from both sides, we get the proof of the property of absolute value of real number. Now the fourth property is modulus of x minus y is greater than or equal to modulus of x minus modulus of y. The fourth property of absolute value of real number is modulus of x minus y, modulus of x minus y is greater than or equal to modulus of x minus modulus of y. To prove this relation, let us suppose x minus y equals to z. Then x will be equal to y plus z after transposing minus y on the right hand side, minus y will be plus y, x equals to y plus z. Now taking modulus on both sides. So if we take modulus on both sides, we get modulus of x equals to modulus of y plus z. So in the third property already we have proved the modulus of the sum of any two real numbers is always less than or equal to sum of the modulus of the given two real numbers. That means modulus of y plus z we can write less than or equal to modulus of y plus modulus of z. Now transposing modulus of y to the left hand side, we'll get modulus of x minus modulus of y less than or equal to modulus of z. Now let us transpose modulus of z to the left hand side. Then we'll get modulus of z greater than or equal to modulus of x minus modulus of y. So according to the rule of inequality, if we transpose the number from left side to the right side and the number of right side to the left side, then the sign of inequality will change. So the sign of inequality less than or equal to changes into greater than or equal to, because left hand side is transposed to the right hand side and right hand side they are transposed to the left side is transposed to the right hand side. So modulus of z we get greater than or equal to modulus of x minus modulus of y. So z means we have supposed x minus y. So replacing z by x minus y, we get modulus of x minus y greater than or equal to modulus of x minus modulus of y, which is the proof of the fourth property. The fifth and the last property of absolute value of real number is modulus of x minus y. The modulus of x minus y is less than or equal to modulus of x plus modulus of y. Modulus of x minus y is less than or equal to modulus of x plus modulus of y. So let's take LHS. Modulus of x minus y. Modulus of x minus y. The modulus of x minus y we can write as x plus minus y, because plus minus is minus. So minus changing into plus, because plus minus is equal to minus y. We know x plus y is less than or equal to modulus of x plus modulus of y from the third property. Modulus of x keeping as it is, modulus of minus y we can write as modulus of y, because modulus of positive numbers and negative numbers both are same. So modulus of x minus y we get less than or equal to modulus of x plus modulus of y. So this is the proof of the fifth property of